Hi, kids. All right. We have a problem here. It says a moving box slides to a stop at 2 meters. If the initial speed of the box was doubled, what would happen to the stopping distance? Okay, so let's say you have a problem like this, and you're like, I'm not really sure where to go with this. Well, let's think about it. Okay, so let's think. Okay, so I'm giving you meters. So I'm giving you a distance. And what would be causing it to slide to a stop? Oh, that'd be friction. So if you think about friction, well, friction's a force. So if you have a force and a distance, you should be thinking about what? Oh, yes, work. So if you're thinking about work, okay, so you say, okay, well, work equals F times D. So now you know that work is also energy. So you should be thinking about, sorry, it's in the glare in it. But you're thinking about that work relates to energy. So if you're thinking about energy, oh, let's see, speed. Oh, what relates to energy? Oh, that would be kinetic energy. So then you should be thinking about, okay, so kinetic energy is 1/2 mv squared. Well, how is work related to kinetic energy? Oh yeah, the work energy theorem, that if you do work, then you change an object's energy. In this case, you're going to change its kinetic energy. So you say, oh, okay, so then I'm going to get work equals my change in kinetic energy. Okay? So now if my speed is doubled, you come over here and go, wait a second, speed is v, so if I double this, it's going to be 4 times bigger. So if my kinetic energy is 4 times bigger, my force is the same because the force friction, it's going to take me 4 times as long to stop. So the answer is, well, if it was 2 meters, now it's going to be 8 meters, okay? But that's one way you can do it. So one way you can do it is kind of reason it through. I know a lot of you guys love math. You just love it. You just love numbers. So let's, if you're somebody that loves numbers, let's make up numbers and solve it a different way. So let's say, okay, so I don't give you a mass, so let's make up a mass. A really easy mass is 1, okay? I didn't give you a speed, so let's make up a speed. Well, another really easy number is 1. Okay, so if I do this, 1 times 1/2, I get 0.5 joules. So that's how much energy I have at the beginning. So at the end, it's going to be 0. So my force, I'm going to end up with F times D equals 0, because final minus initial. Okay, and I end up with this. Oh, but I know my distance is 2 meters. Okay, and I divide, and I get my force is negative 0.25 newtons. Okay, well, a couple things. Negative, what the heck does that mean? Oh, well, it means it's going the other way. But we already knew that because we're doing negative work because I'm taking energy away. I'm taking kinetic energy away. So now I know my stopping force. Okay, so now what I'm going to do is I'm going to use numbers again and say, okay, I'm going to double my speed. Well, if I double my speed, my kinetic energy is now going to be 1/2. Well, my mass is still 1. This is going to be 2. If I do the math, 4 times 1 times 1/2, that's 2 joules. So then I end up with work equals change in kinetic. So I have work equals negative 2 joules. My force I already know is negative 0.25. And I can solve for my new D. And when you do it, 8 meters. Yay! Bye, kids!